Okay, I'll go through one more example of geodesics, metrics, Lagrangian, Euler-Lagrange equations. I'll start off with, I'll just make up an expression for a metric. So ds squared, elementary line element, is equal to, what shall we have? 4 plus 3xy dx squared plus 2x over y dy squared. Is that visible? I'll focus that a little bit better. That's worse. That's worse. All right. I think that's about as good. I'll use a thicker pen. Okay, so what we have here, ds squared equals 4 plus 3xy dx squared plus 2x over y dy squared. First step, what's a Lagrangian? Okay, replace dx's with x dots, dy's with y dots, so L is equal to 4 plus 3xy x dot squared plus 2x over y y dot squared. Okay, there's the Lagrangian. For working out trajectories, L is equal to 1. For particles, L is equal to 0 for light rays. What we're going to do here is try to work out the Christoffel symbols. So we're going to use the Euler-Lagrange equations to work out the Christoffel symbols. There's going to be, it's in x and y, it's in 2 dimensions, so there's going to be 8 different Christoffel symbols. So let's see, first of all, Euler-Lagrange equation, d by d lambda dl dx dot minus dl by dx is equal to 0. That's the first Euler-Lagrange equation. So we need to differentiate the Lagrangian, and this will give us the equation of motion. This will give us an x double dot term, which will give us the equation of motion. X double dot is equal to 0 for the non-accelerated case, but in curved space-time, if a geometry given by this, we're going to get different equations of motion. Okay, so let's do this step by step. So d by d lambda, dl by dx dot. Let's differentiate L with respect to x dot. Well, we can see, here's the x dot, so differentiating this with respect to x dot. The x dot squared term will go to 2x dot. And with this factor in front of it, so it's going to be 4 plus 3xy times 2x dot. That's the derivative of this whole thing with respect to x dot. Minus dl with respect to x. No, I've made this a bit too complicated for myself, but we'll do it. Derivative of L with respect to x. Okay, so here we have the 4x dot squared term. There's no x in there. Here we've got 3xy x dot squared. There's an x, hooray! So the derivative of that with respect to x is going to be 3y x dot squared. Marvellous. And here we have another x here, so 2x over y, y dot squared. Derivative of that with respect to x is going to be, it's minus there, so we get the minus going to be minus 2 over y, y dot squared. And that whole thing must equal 0. Perfect. Okay, so now I need to do the full derivative of this term here with respect to lambda. So let me just write this out. So this is d by d lambda of, so there's a bracket there, the 4 is going to give me an 8 x dot plus 2 times 3 is 6 x y x dot minus 3y x dot squared minus 2 over y y dot squared is equal to 0. Okay, good. Now then, let me slide the page up a little bit. So what I need to do now is actually to do this derivative here, the full derivative with respect to lambda, our affine parameter, often equal to the proper time. And so I need to differentiate all of this with respect to lambda. So I could break this up to be the derivative of 8x dot with respect to lambda. That's simply going to be 8x double dot. X dot is simply dx d lambda, so x double derivative with respect to lambda of x dot is x double dot. So that becomes it. This term here is going to require a little bit more thought, but this is a product rule where there's 3 terms in the product. So it's going to be 6x times y times the derivative of this one. So we're going to get a term that is x, y, x double dot. Then we're going to have a term that is going to be x, y dot, x dot, differentiating that one. And finally, differentiating this one here, it's going to be x dot, y, x dot. There we go. So that's the whole thing, minus 3y x dot squared minus 2 over y dot squared is equal to 0. Just about all fits on. Perfect. Now then, we need to do a little bit of rearranging. Let's collect the terms together. In particular, let's start off with our x double dot term. X double dot. What do we have to multiply that by? We have an 8 from there, and we have a plus 6xy. 1 from there, and the 6xy from there. So there's my x double dot terms. I then have some x dot squared terms, if we look at that. And so the coefficients in front of that we have here, this is x dot squared. That has a 6y in front of it, so there's 6y. There's also an x dot term, squared term there, which has a minus 3y in front of it, minus 3y. Any more x dot squared terms? No. What about y dot squared? No, 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 no. Yep, 1 minus y dot squared term there. So we have a, let me do it this way, plus y dot squared. Coefficient of that is minus 2 over y. And we now have x dot y dot term there as well. So we have a plus x dot y dot term with a coefficient which is just equal to x. Let me just check. We had kind of 1, 2, 3, 4, 5, 6 terms there, and 1, 2, 3, 4, 5, 6 terms there. So I don't think I've missed anything out. And this whole thing is still equal to 0. Perfect. Now to get this into the form of the geodesic equation, we need to have an x double dot plus something equals 0. Okay, and so we therefore need to divide through by 8 plus 6xy. We give x double dot plus, now 6y minus 3y is 3y, so we're going to have an x dot squared term here, times 3y divided by 8 plus 6xy. We're then going to have a plus y dot squared term, and this is going to be multiplied by minus 2 divided by y times 8 plus 6xy. And finally we're going to have our plus x dot y dot term, which is going to be times an x divided by 8 plus 6xy. That whole thing is equal to 0. Perfect, perfect, perfect. Now the final step is simply to read off from here what the Christoffel symbols are. Okay, so we're looking at the x geodesic. So this is all going to be x, gamma x. And the first one is the gamma x, x term is simply the coefficient of this one here. So this is going to be 3y divided by 8 plus 6xy. The gamma x y term is the coefficient multiplied by the y dot squared term. This one here. So this is going to be minus 2 over y 8 plus 6xy. And the final one, let me just slide this up a little bit, is going to be our we know that gamma x xy is the same as gamma x yx. And that's going to be this coefficient here. There's only one of those terms going to kind of divide it in two to share it between each of these. So this is actually going to end up being is equal to x divided by dividing this thing by 2. So half of this is going to be 16 plus 12 xy because of each of those terms. Okay, so now we have our 1, 2, 3, 4 Christoffel symbols for the gamma x's. You go through the whole thing again and work out your Christoffel symbols for your y, and that would give you 1, 2, 3, 4, 5, 6, 7, 8. The 8 Christoffel symbols needed for this particular fairly bizarre metric.